Hi everyone, welcome to this new series on understanding the data science and pre-processing techniques used in machine learning and data science project. In the previous video, we talked about general inspection and also handling duplicates. In this particular video, I'll be covering the missing value analysis. This is going to be a little long topic, so I've divided into two separate parts, so that means there will be two different videos. Yeah, here it is, missing values part one. We will try to understand what is missing value, why they happen, and how do we mitigate them. What are the various strategies to handle missing values? So what is missing value? The values which are missing, basically absence of any specific piece of information in variables or columns. And when the value is missing from for a particular variable in a given row, it is called missing value, and sometimes it is denoted as NA or sometimes it's NaN. Meaning of missing value is broader than complete absence of values. Let's try and see what are those different types of um, or representations for missing value. You could have complete absence of a value, which is like null value in a column or not applicable. Sometimes the columns have a specific mention of not applicable. Sometimes you could have underscore as the only value in the column. In some data sets, that might be the case, and that can be construed as missing value. You could also represent, or you could also have instances of missing values, which are denoted by question mark. Sometimes it's empty string, especially the data on text. Um, type data, you could have empty strings as well, and that can be indicator of missing value. Placeholder text, sometimes in the data set we have explicit mention like unknown or missing or not known, not available, like here in this case. So these are placeholder text. Custom code is also a way to indicate missing value. Sometimes these large numbers or minus 999 can also indicate uh, missing values. And you could also have special arrangement or indicators for missing value. So that means missing value is not simply the absence of a value. It has a larger context, and depending on what is the definition or what kind of data is there in the data set and how the missing values are represented, we have to come up with special techniques. So what is handling missing values and why it happens? Handling missing values means coming up with scripts or methods, appropriate methods to substitute those missing values. So data points that are not present or they have been defined wrongly probably or undefined also, they need to be handled. So that's what the meaning of handling missing value. It can occur for many reasons. Let's take a look at some of the reasons here. It could be data entry error. It could be because of sensor issues. Let's say you're collecting data from IoT devices, and because of the malfunction, you could have missing values. Let's say you have the data based on surveys, and sometimes the respondents may not choose to provide answers to particular question because of privacy or confidentiality reasons. Some of the data might be missing. It could also be because of improper or incorrect data assimilation or data engineering methods that we have. Missing values may occur naturally as well, maybe because of the process is not generating data for that particular column in that row. It's very important to handle missing values because that can lead to biased conclusion. If the missing data is not random, that means it is having some kind of a pattern. Many machine learning models cannot deal with data sets with missing values. So we have to handle missing values. Preservation of data integrity is the utmost importance in data science and machine learning. So we have to handle missing values. There are 4 different types of missing value. We will address each one of them. The first one is structurally missing. Then we have missing completely at random. We will try and understand that. Missing at random, and sometimes it could be ignorable. This is quite difficult. We'll see why it is difficult. So structurally missing data, it refers to specific pattern of missing value in a data set. That means this type of missing data has specific pattern. This is not random, but rather it is predictable. Structurally missing data follows some predictable pattern and it is not a random instance. Let's take a look at an example here. For example, let's say we have a data set and we have collected information on health parameters. The blood pressure and cholesterol level, they are not applicable in some cases. Let's say the patient has come for a specific treatment and that treatment is about, let's say, lifestyle or, some kind of disorder where the blood pressure and cholesterol level measurements may not be applicable, so they can be not they can be not applicable, or rather they would be missing. Sometimes vaccination status can be also incomplete for some patients because that's not relevant in that case. So it could be incomplete. Now, incomplete means the patient hasn't gone through the complete vaccination cycle. And likewise, you could also have indication for diabetes. Some places it may not even be present because it's not relevant. Now you notice here, these are all instances of missing values because of structure of the table that we have. And that's why it's called structurally missing value or missing value due to the structure of the table. So we have to pay attention to the table structure that we have and try and see if there are missing values because of the arrangement of columns or inclusion of columns. So how do we detect missing value? So one method is to use descriptive statistics. That means examine the data for the variables with missing value. And you're going to compare the rows with complete cases with the cases which have missing values. So it's going to be a little, tedious manual work. You can automate this process. You can also write scripts and, compare, if the instances of missing data is related to, or rather find the instances of missing data first in the first place. The other method is to train a machine learning model. Now, this is a little bit advanced method. As I mentioned, some of the data processing techniques may involve advanced techniques which would need machine learning implementations. So essentially, we are now here predicting the missingness of the column based on the other variables in the table. Essentially, the feature importance analysis is conducted here. If you're not familiar with machine learning, don't worry about it. We are going to have a separate series on machine learning. Once we do that, then we can come back to this point and try and understand this type of solution for detecting the structurally missing data. Let's take an example of a machine learning model to predict the missingness based on other variables. And the columns are, let's say, age, gender, height, and weight. And we are interested in finding out if the missing value in the BMI column, let's say here, NA, NA, and NA, are they structurally missing? Means, have they got any sort of relation with the remaining columns or remaining predictor column? So first, get the data set with the required column. Focus on the column where you want to detect the missing value. In this particular case, we would like to predict the BMI is missing because of the other available information. Essentially, what we're trying to do is we are predicting BMI based on the other columns here. And that's machine learning. Again, I mean, if you're not familiar with machine learning, don't worry about it. When you learn about the machine learning in the subsequent playlist, we can come back and see what this method is all about. So these steps that we use in this method is essentially machine learning. So make sure the other predictor column, let's say age, gender, if you notice here, height has missing value, weight has missing value. You cannot have this. You need to treat these column, or you need to fill this column with some method first. That means for all the predictor columns, you must have relevant data so that you can build the machine learning model. That's what is a pre-processing step. Target variable we have decided is going to be the BMI column, which is going to be our target variable. Now run the machine learning, that means train a machine learning, and then essentially do a feature selection. What does it mean? Feature selection means which column significantly predicts BMI. So in the BMI column, we will have something like 1 here and 0 here, 1 here, 1 here, and 0 here. So we are making like a binary classification problem. And we are trying to see if gender has a strong relation with BMI, or height has a strong relation with BMI, or weight has a stronger influence on BMI. Essentially, we're looking at which columns are indicating or attributing to the BMI. That means we can say, let's say, age is a very strong indicator for body mass index. So that means, for example, then you can make a conclusion that people with no BMI mentioned, they have something to do with very advanced age, or could be like, they are children. So that kind of inference you can draw from the machine learning model. And then once you have that kind of conclusion, you can decide what to do with the missing values here. So that's the feature selection step. Here we are trying to find out which columns are influencing the BMI. So they would be indicative of the BMI column values in terms of missing. So that's the step here. And essentially that is done with the help of a model training. That means you choose certain machine learning model, could be decision tree, could be logistic regression, could be the neural net, depending on uh, the the type of data that we are having. So structurally missing data, two very important points that I have highlighted. The other points are really need to study the design. Make sure you are excluding the irrelevant columns as much as possible, and consider the time points and events. That means exclude the assessment or measurements that are not applicable, right? So that those are basic diligence that you need to apply. But make sure we consult domain experts, and once you have a decision, impute with care here, because a lot of subjective assessment and conclusion might be needed here. So that's structurally missing data for you. Now the next is the missing completely at random. So let's take an example here. Consider you have a survey where the respondents are asked about, let's say, income, age, and education level. If the data on income is missing because some of the respondents are not responding or they are choosing not to disclose their income, and this choice is not related to the other columns here. Then now this kind of missingness is considered completely at random. So let's take an example here. Let's say you have student data, the hours of sleep and GPA and the extracurricular. Some of the students, may not want to provide information on extracurricular, so it's not applicable. So these kind of missing values have nothing to do with the other column, and that is called missing completely at random. So hours of sleep, GPA, extracurricular here indicates whether it is absent or not applicable. So here the missingness in the extracurricular column is completely at random. Missing completely at random. That means probability of missing value in this column is unrelated to both observed and unobserved data. So what is observed data? So these are observed data here. These are observed data. What are unobserved? Unobserved are the data which are missing here. So these two terminologies are important in analyzing the missing values. So this is called missing completely at random. Ways to handle missing completely at random. You can remove the observation with the missing value. That's one of the options. Let's say you have these instances where you have completely at random missing values highlighted in green, and after deletion you don't have that data. That's one option. Another one, replace the missing values with the mean median mode of the observed value. That means this particular extracurricular activity, since this is categorical, we will look at the mode, and let's say the mode is yes. That means the yes occurs the most number of times, so we can go ahead and substitute yes. So it's called imputed meaning we are imputing that value in that particular place. So this is another option that you have. One more option is used is called multiple imputation. This is pretty strong and resilient method. Let's see why it is so. We are going to generate multiple data sets with imputed values, each representing a possible estimate of the missing value. For example, here, let's say these two are missing values, and then there are missing values in the other columns as well. So what we do here is we are going to create multiple columns, multiple copies of the data set, and each one with the variation in terms of the method we have chosen to impute or estimate the imputed value for the missing places. And then you impute it. For example, GPA, we can impute using mean method. Extracurricular, we can impute using mode method. You can have a mix of different methods. You can have mean, median, or you can have a custom function, and so on and so forth. So multiple imputation requires some design thinking and choice of imputations, different possibilities, and combinations of imputations need to be considered. And then you are going to end up with, let's say, the data sets, imputed data set 1, 2, and 3, and you notice the values are different in each of the copies. And what we do here finally is we're going to do an average of all these three. So we're going to do the average of this and we put it in the final. So essentially we combine the results using some Rubin rule, or you can use simple averaging technique as well. So the advantage of multiple imputation is a sense of average that you are building into the data set, especially in the places where the values are missing. So that is how you handle the missing at random. Is a missing data mechanism where the probability of missing values depend on the observed data but not on observed data. Now this is slightly different. Let's say here, in other words, once you account for the observed variables, the missingness is random. Let's take an example here. So let's say we have a data set here, the test scores and hours of study, and let's say this particular column has missing values in these places here. Now, so how do we handle such cases? Handling missing at random involves addressing the missing value considering the observed variables in the data set. What are observed variables? The variables which are present in the data set. So based on the data which are present in the data set, you're going to make some estimate for the missing value. So the imputation methods now will utilize the present values in the other observed variables to impute into the missing places. Now here then we can use again machine learning methods. If you're not familiar with machine learning methods, no problem, just hold on and we will complete the machine learning primer very soon after this playlist, and then you can come back to this topic. So using machine learning method, we can predict the places where these values are missing. Again, it is pretty similar to the structurally missing data and how we applied machine learning in that particular case. Here also we can apply machine learning method to predict. The other method is very easy. You can use mean, median, or imputations within a subgroup. So what does it mean? Let's go back and see what we can. So here, the machine learning methods would be, then we make this column as y, and then the remaining column would be your x. Let's say this is x0, x1, and x2, and so on and so forth. And based on the other column, you're going to predict for the missing value. This is the approach number one, which is a machine learning method. The other one method that is based on subgroup is find out, this one based on mean or median, based on the other category for example, the attendance. So you look at the yes, and let's say this is for yes, and similarly, if there is no, then just look for all the observed value here for no and substitute. And for yes also, look for all the values in the observed places and do the average in terms of mean or median and substitute in these places. I hope it's is quite easy to follow. Now, some of these methods will require us to write scripts or machine learning models. Not everything is provided by default from Pandas or Python side. Okay, so the fourth type of missing value is non-ignorable, or also called missing not at random. Now, this is a slightly difficult proposition, but this is also quite common in data science. Let me show you an example here. Let's say we have a data set on income and education and likelihood, and some of the individuals with really high income may not like to report their exact income. So leading to missing values that are related to unobserved uh, values. For example, here income here, you know that, I mean, this is not related to any of the values which are present in the observed instances. And they are not present because the respondent has not given that information. It is very hard in that case to substitute for such missing values. So the key point in this particular case or type of missing value is dependency on the unobserved value. So this is completely based on the unobserved value, nothing to do with the values which are present. So the probability of missingness is related to the actual values of the variable that is actually missing. And that's the hardest part. And it is systematic as well. It introduces some kind of a bias because it's very hard to estimate for something which we don't have any basis for. And it leads to some kind of distortion in the analysis. Very hard to impute, as I mentioned earlier, and causes information loss because of such instances. And in order to address this particular type of missingness, this requires serious modeling of those missing data. Now I'm going to show you a simple Python demo using Python Pandas, and I'll just show you some of the basic features provided by Pandas to handle missing values and some of the strategies that we can apply, mean, median, and all that. Some basic example, we'll take a look at it. Okay, here's an example here, missing value analysis using Pandas. I'm going to take a simple data set, California housing. It is freely available on most of the platforms like Kaggle or UCI. Even scikit-learn also has a version of California housing. This dataset has 20,000 samples, 10 columns, and the columns are longitude and latitude. Housing median age, that means what is the median age of the house within a block. So let me just give you a brief outline about this data set. This is like, let's say, the California region, and they have divided this into different blocks, and each of the block has houses here. So, and for each block, so essentially when you see here 20,000, that means they have divided the California region into 20,640 blocks. And for each of the block, there are many houses, and they take one representative house to represent that block. Okay. So housing median age means the median age of a house in the block, let's say 4 years. Okay, so that is what that column is. Total rooms means total rooms within a block. So they have taken all the houses, and let's say the total room is 500. Total bedrooms in that block, let's say, 400. And population, how many people live? Maybe, 2000. And household, total number of households, again, let's say 300 or 200 number of households. Median income, so what is the median income of this? Let's say, $15,000, something like that. Ocean proximity, that means it is the area or the block is closer to the ocean or not. So there are 5 categories here. In bay, slightly closer to the ocean, 1 mile away, in the city, something like that. So there are like 5 different values here for ocean proximity. Median house value is like typical house price here, let's say 200,000. Okay, so this is the type of data that we have, and we'll see, how do we handle missing values. So there is one particular column which has missing values. Total bedrooms here has 207 places where the values are missing. So the strategy one is to fill with the mean. So what you can do is essentially look at the observed values and take the mean of that and then substitute. This could be one of the approaches, and after doing so, you will not have any missing value. Now, this may not be the right approach. I mean, this is just one of the approaches. I'm just showing you what Pandas is actually providing. So read the data again, and you have 207 instances of missing value. Another strategy can be describe the total bedrooms, and where the standard deviation is 421, the minimum is 1 bedroom, the maximum is 6,000 bedroom, right? So now you can do certain statistical analysis to pick a right value by looking at this. You can also choose a mean from here. So that's 537 as the mean here. You can go with different values. Let's say, I can go with 25th percentile or 50th percentile or 75th percentile. So different strategies, different options that you can experiment with to replace the missing value in that column. So before we take a decision, what method we should apply, it's very essential to do some kind of a plot and an understand. So what I've done here is this is the complete data set that I have plotted. The red ones are the rows where the value in that column of a total bedroom is missing. And as you notice here, the values or the households where the values are missing, they are near the ocean. So this side would be the ocean, and the number of rooms or bedrooms are missing in near the houses near the ocean. So it really doesn't make sense to do a total average of this, and that's going to be a wrong depiction of the imputed value here. So the other approach that we can make is we can take a look at the houses within certain radius, and we can take the average here. Let's say for this we can take a certain radius and we can take an average here, certain radius we can take an average here, like that. That can be an approach, and that is why I mentioned it requires domain or data understanding as well. Some more methods that we can, we can look at is, let's say, if this value is missing, the house near to this probably would be right fit, or the closest house is here. If that house is 3 bedrooms, let's substitute 3 in that place as well. So in my second part of the options that we have for missing value treatment, the video number 2, I'll be covering certain advanced interpolation techniques. For now, I'm just leaving you with this thoughts that missing value analysis is one of the hardest, tasks in data science and data processing. Let's take a look at another example. This is NBA dataset where you have the team members' name and the position that they play for and the age and the height and the college they represent. And you see certain places are having null values. Now, the other strategies can be that if the data is sorted in college wise, let's say the team wise, and it's very likely that this guy, is going to represent the same college, right? So there are instances where the data is ordered in a certain sequence. Then Pandas provides certain easier methods to handle the missing values here. So let's see those methods. For example, I can fill the column with a missing value with a fixed MIT as a fixed value wherever the values are missing. Or I can use the methods like forward fill. That means Georgia state will be filled into this particular NaN. And the once filled in, again, the Georgia state will be used to fill in the next value. So you can use these methods when the data is actually naturally sorted in a particular order. For numeric values, I mentioned to you, we can have either mean or median method. So here Pandas provides you with that method. Let's say the salary column, there are some missing values. You can choose mean, median, or minimum or maximum. Now this strategy completely depends on our understanding of the data, and that will guide us to choose mean or median. When we use mean and when we should use median, the idea is if the data is normally distributed, let's say the salary column is typically normally distributed, then in that case take the mean. And if the data is not normally distributed, it is having a skew, then you take the median of that or central value of the data series. So these kind of considerations you have to make based on the understanding of the data and the data distribution. So that's pretty much in this code walkthrough. I will show you some advanced methods in the second video. So we talked about the missing values handling, and that was part one. And we used pandas for the demo. There were 4 types of missing values: structurally missing, completely random, completely not random, and missing at random. So those were 4 different types of missing value that we handled. In the second video, I'll talk about certain interesting techniques using statistical interpolation method, and some of these methods may require machine learning as well. As I mentioned, again, don't worry about it. When you complete your machine learning primer topics, then you can come back to these certain strategies that we use, which are based on machine learning techniques. That's it for now. See you in the next session.